Hello everyone, welcome to lecture 21. This is going to be on section 7.4, which is on the other trig functions. And we're going to look at the other trig functions as a function of any angle, right? So we looked at sine and cosine pretty carefully. Now we're going to look at tangent, cosecant, secant, and cotangent. So let me start by drawing a circle of radius r, and then we will define what each of these trig functions are. So let's say this is my circle. So this point right here, let's say, is the point xy. And the radius, so the distance from the origin to the circle is r, and this is the angle theta. Okay, so I just kind of randomly chose the second quadrant to draw everything in. So now we want to talk about the other trig functions, which are tangent. So we spell that, if we write it out, it's T-A-N-G-E-N-T. Cosecant. Secant. And cotangent. Okay, so from before, right, we know that the sine of theta, by definition, is going to be y over r, right? And in this case, the y is positive, r is always positive, so sine of theta is positive in the second quadrant. Right? The sine, remember, depends on what quadrant you're in. Cosine of theta was defined to be x over r. In this example, the cosine is going to be negative, right? Because the x value is negative. Then here comes the new one. So tangent of theta is the same as the sine divided by the cosine. So it turns out we can write everything in terms of sines and cosines, which is nice because we can refer back to sine and cosine, which we know fairly well now. So remember, sine is y over r divided by, and cosine is x over r. And if you simplify this, this is simply going to be y over x. Okay, so that's tangent. Then cosecant, the reason why I'm writing it next to the sine is this is 1 over sine. So it's defined to be 1 divided by sine of theta. So that means, remember, sine of theta is y over r, so this is going to be flipped, right? This is like 1 over y over r, which is r over y. So it's the inverse, it's flipped. Secant of theta is 1 over cosine. So remember, cosine is x over r, so secant is going to be r over x. And then finally, cotangent is 1 over tangent. But since tangent is y over x, cotangent is going to be x over y. Right, so those are the definitions of all 6 trigonometric functions. Okay, so here's an example. Let's say, let me do another page here. Let's say we're told if theta is 9 pi over 4, so if the angle is 9 pi over 4, I want to find exact values for basically all 6 trig functions, right? So for sine of theta, cosine of theta, tan of theta, cosecant of theta, secant of theta, and cotangent of theta. Okay, well, it's the same idea as to how we did this with just when we were focused just in the last section on sine and cosine. I need to figure out the reference angle first, right? Because the trig function of any angle is the same as a trig function of its reference angle, except you have to be careful with the sign, whether it's positive or negative. So how do I find the reference angle? Well, 9/4 pi is basically, remember 2 pi would be going around once. And then I'm going a little bit more, right? Because 9 divided by 4, you could divide this out. 9 divided by 4 is 2 point something. So it's a little more, it looks like I'm going to be in the first quadrant. So to figure out exactly what you would do is you would take 9 pi over 4 and subtract out 2 pi to see what's left over. Well, 2 pi can be written as 8/4 pi. Right, basically I just multiply by 4 over 4, so I had the same denominator. And then if I start subtract now, I have pi over 4. So the reference angle is pi over 4. Okay, it also happens, I mean, it's also a coterminal angle, right? But in this case, it is the reference angle because it's measured relative to the x-axis. So this angle right here is pi over 4. Okay, well, we know the values for sine and cosine of pi over 4, right? Remember, if you forgot, you could draw out the 45, 45, 90 right triangle. So 45 is the same as pi over 4. So remember, this is 1, 1, radical 2, right? So sine of pi over 4 was equal to opposite, which is 1 over hypotenuse. And then if I rationalize the denominator, this is going to be radical 2 over 2. And then cosine of pi over 4 was adjacent divided by hypotenuse. But then if I rationalize the denominator, this is also going to be radical 2 over 2. Okay, so I know that sine of pi over 4 is radical 2 over 2. I know cosine of pi over 4 is radical 2 over 2. So how do I figure out tangent? Well, tangent, now that once you know sine and cosine, you basically know everything, right? Remember, tangent is sine of pi over 4 divided by cosine of pi over 4. So this is radical 2 over 2 divided by radical 2 over 2. And what is that? That's equal to 1. Then cosecant of pi over 4, well, that's the same as 1 over sine. So you have to remember that, right? Cosecant is 1 over sine pi over 4. So this is going to be 1 over radical 2 over 2. So if we simplify this, right, this is going to be, you can write it as 1 over 1 divided by radical 2 over 2. So to solve this, I multiply the numerator times the reciprocal of the denominator, and I'm going to get 2 over radical 2. But then we probably want to rationalize the denominator. So I need to multiply by radical 2 over radical 2. So this is 2 radical 2 over 2. And then the 2's cancel. So this is just radical 2. So cosecant of pi over 4 is just radical 2. Now secant, that's going to be 1 over cosine. So in this case, it turns out it's going to be the same thing, right? So it'll be 1 over radical 2 over 2, but that's really just 2 over radical 2. And then if I rationalize the denominator, again, I'm going to get radical 2. And then cotangent of pi over 4 is the same as 1 over tangent of pi over 4. So that's going to be 1 over 1, which is also 1. Okay, so really it comes down to what we learned in the previous section, right? Finding the values for sine and cosine. And then once we have those, we can get all the other trig functions because they're all related to sine and cosine. All right, let's do the special angles where the angles are right on the axes for each of those 6 trig functions. So the first case, let's say my angle is 0 degrees. So that means, and actually I'll assume that the radius of the circle here is radius 1. Assume it's a unit circle just to make things easier. So what are the coordinates? So if this is like 0 degrees, theta equals 0 degrees. What are the coordinates at that point? If r equals 1, the radius is 1, well, that's going to be 1 comma 0, right? So my x is 1 and my y is 0. So based on that, I can get all of my trig functions, right? So I want sine of 0 degrees, cosine of 0, tan of 0, cosecant, secant, and then cotangent. So sine of 0, remember, is y. Sine is always y over r. So in this case, the y is 0, the r is 1, this is equal to 0. So sine of 0 degrees is 0, right? We know that from before. Cosine of 0 is x over r. So this would be 1 over 1, which is 1. So cosine of 0 is 1. Tan of 0 is y over x. So this is going to be 0 over 1, which is 0. Cosecant is 1 over sine. But what's 1 divided by 0? That's undefined. Okay, the other way you could have done this is, remember, since sine is y over r, cosecant is going to be r over y. So 1 over 0, it's still going to be the same thing, it's undefined. Then secant is 1 over cosine. Well, cosine of 0 degrees is 1, so this is 1 over 1, which is 1. And then cotangent is 1 over tangent. But tangent of 0 is 0, so this is 1 over 0, so this is also undefined. Okay, and actually, because going around once, so I did theta is equal to 0 degrees, but this is also true, so these are all the same values if theta equals 360. Or any multiple, right, any integer multiple of 360, and you're going to get the same exact values here. So you can plug in sine of 360, cosine of 360, tan of 360, and so on, and you get exactly the same values, 0, 1, 0, undefined, 1, undefined. Okay, the other special, so there's a couple more, right? Let's look at 90 degrees now. So again, I'm assuming that I have a unit circle. So the point on the circle, this is r is 1. This point would be 0, comma 1, right? That's our x and y value. And this is 90 degrees. So again, now I want sine of 90, cosine of 90, tan of 90, cosecant of 90, secant of 90, cotangent of 90. Okay, so sine of 90 by definition is y over r. So that's going to be 1 over 1, which is 1. Cosine is x over r. So that's going to be 0 divided by 1, which is 0. Tan of 90 is y over x. So that's going to be 1 over 0, which is undefined. Cosecant is 1 over sine. So actually, I'll do it the other way for now. Remember, if sine is y over r, then cosecant must be r over y. So that's 1 over 1. That's still 1. Secant is 1 over cosine, so that must be r over x. So that's 1 over 0, which is undefined. And cotangent is 1 over tangent. So if tangent is y over x, this is x over y. So that'll be 0 over 1, which is 0. Okay, so those are all the trig functions when the angle is 90 degrees. Okay, a few more. 180. So that would be like this, right? This angle right here is 180 degrees. So again, if we assume a unit circle, r is 1, then this point is going to be negative 1, comma 0. That's x, y. So sine let me just write all these out first. So sine, cosine of 180, tan of 180, cosecant, secant, and then cotangent. Okay, so again, let's use our definition, right? It's y over r. So the y in this case is 0. The r is 1. This is going to be 0. So sine of 180 is 0. Cosine is x over r. Well, the x is negative 1, right? But the r is 1. The r, remember, is always positive. That's going to be negative 1 divided by 1, which is negative 1. Tangent of 180 is y over x. So that would be 0 over negative 1. Well, that's just 0. Cosecant is 1 over sine, so that's going to be r over y. So that would be 1 over 0. That's undefined. Secant is going to be 1 over cosine, so that's r over x. So that will be 1 over negative 1, which is negative 1. And finally, cotangent is 1 over tangent, so instead of y over x, it'll be x over y. So that'll be negative 1 over 0. That is also undefined. Okay, and then finally, 270 degrees. So that would be down here, right? So if this angle were 270, and again, we say r is 1, then this point right here would be what? It would be 0, negative 1. Right? That'd be x, y. So now if I do sine of 270, cosine of 270, tan of 270, cosecant of 270, secant of 270, and then cotangent of 270. Okay, so sine is y over r. So that's going to be negative 1 over 1, which is negative 1. Cosine is x over r. So that'll be 0 over 1, which is 0. Tangent is y over x. So there'll be negative 1 over 0. That's undefined in this case. Cosecant is 1 over sine, so that's going to be r over y. So that'll be 1 over negative 1, which is negative 1. Secant is r over x, right? It's the same as 1 over cosine, so r over x. So this will be 1 over 0. This is undefined. And cotangent is 1 over tangent, so this is going to be x over y. So that'll be what? 0 over negative 1, which is 0. Right? So really, the important ones to know, again, are just sine and cosine. If you know sine and cosine, you can work out all the other ones. Okay, let me go back. So I've mentioned this in previous sections, but let me go back to the quadrants and what the correct signs are, SIGN, for each of those trig functions. So here's my coordinate system. So here's quadrant 1, right? Quadrant 2, quadrant 3, and in quadrant 4. So remember, in quadrant 1, all of the trig functions are positive. So what does that mean? It means sine of theta, cosine of theta, tan of theta, cosecant of theta, secant of theta, and cotangent of theta. They're all positive in that first quadrant, right? In the second quadrant, remember we said we had this mnemonic. So all students. So that was to remind you that sine, right, is positive in the second quadrant. But if sine is positive, its inverse, 1 over sine, is also positive. Remember, 1 over sine is cosecant. So really, sine and cosecant are positive in that second quadrant. All the other trig functions are negative in the second quadrant. Just sine and cosecant are positive. Then in the third quadrant, we had, so it was all students take. So that reminds you that tangent must be positive, right? Tangent of theta is positive, but also its inverse, 1 over tangent, also has to be positive, right? And so that's cotangent. So tan and cotangent are positive in the third quadrant. All the others, sine, cosine, cosecant, secant, those are all negative in the third quadrant. Just tangent and cotangent are positive. And then it was all students take calculus. And you can make up other mnemonics as well, if you don't like that one. So that reminded you that cosine was positive in the fourth quadrant, but also 1 over cosine, which is secant, must also be positive. Okay, so that's just a reminder. All students take calculus, so all are positive in the first quadrant. Second quadrant, students, that reminds you sine is positive, but also 1 over sine, which is cosecant, has to be positive. Third quadrant, take, tangent, cotangent are positive. And the fourth quadrant, calculus, reminds you that cosine and then 1 over cosine, which is secant, are positive. All right. So here, let's do an example. Let's say I have let's say we're given an angle. Theta is equal to negative 13 pi over 3. And given that angle, I want to find the sine, cosine, tangent, cosecant, secant, and cotangent of that particular angle, right? Of negative 13 pi over 3. Okay, so first thing we have to do is we have to find, first of all, we have to find a coterminal angle, right? That's within either 0 to 360 or the other way around, 0 to 2 pi if we're using radians. And then we want to find the reference angle. So if you think about this, right? First of all, if you divide this out, you're going to get around 4, right? 4 and 1/3 if you divide it. So it looks like if I subtract let me show you this first. So first of all, it's negative, right? So it's going clockwise. So if I go once around, that's going to be 2 pi, right? But that's like 6/3 pi. Then if I do another time around, that's like 12/3 pi. And it looks like I'm doing another like 1/3 pi. So it looks like I'm going to be in that fourth quadrant. But let's figure this out. So we have 13/3 pi. Looks like I went around twice. So I want to subtract out 4 pi. So I need to rewrite this so it has this common denominator. So I multiply by 3 over 3. So this is 13/3 pi minus 12/3 pi. And that is equal to pi over 3. Okay, except it's negative, right? It's negative pi over 3. It's going clockwise. But what is the reference angle here? The reference angle only refers relative to the x-axis, right? So even though I'm measuring that, the reference angle is simply going to be pi over 3. Right? This would be the reference angle. And remember, trig functions of any angle have the same absolute value as the trig function of the reference angle, except that the SIGN, the sign, might be different. So basically, I need to figure out sine, cosine, tangent, cosecant, secant, and cotangent of pi over 3. And then all I need to do is correct the SIGN to get the trig functions of negative 13 pi over 3. Okay, so let's do that. So based on what we just learned, I want to find the sine of pi over 3, the cosine of pi over 3, the tan of pi over 3, the cosecant of pi over 3, the secant of pi over 3, and the cotangent of pi over 3. Okay, so again, for me, it's easier to think in terms of degrees, right? So remember that pi over 3 radians, if we multiply by 180 degrees over pi radians, you're going to find, right, pi's cancel, 3 goes into 3 once, 3 goes into 180 60 times. This is the same as 60 degrees. So if we have our, I'll just draw it on the bottom here. If you don't know these cold, just draw your 30, 60, 90 right triangle. Right, so this is 60 degrees. This is 30 degrees. Actually, let me draw this a little bit bigger. Hold on. I'll do it over here on the side. So I have okay, so this is my right angle, right? This is 60 degrees, which is the same as pi over 3 radians. That's the angle we want. This was 30 degrees, which is pi over 6 radians, but I'll just leave it at that. And remember, the lengths of these sides, if we call the short leg 1, the hypotenuse is 2, and the long leg is always radical 3. So sine is going to be opposite over hypotenuse. So sine is going to be radical 3 over 2, right? Sine of 60, or sine of pi over 3, is radical 3 over 2. So sine is radical 3 over 2. Cosine was adjacent over hypotenuse. So if you look at the adjacent, right, that's going to be the 1. So 1 is adjacent to the pi over 3 angle here over hypotenuse. So it's 1/2. This is 1/2. And then tangent is opposite over adjacent, or it's sine over cosine, however you want to think about it here. So if I just think of it as opposite over adjacent, it's going to be radical 3 over 1. So this is just radical 3. Cosecant is 1 over sine, right? So this is, I'll write it out in detail, 1 over sine of pi over 3. So this is going to be 1 over radical 3 over 2, but that's the same thing as 2 over radical 3. And then you could rationalize this by multiplying by radical 3 over radical 3. You're going to get 2 radical 3 over 3. So that's cosecant. Secant is 1 over cosine. So remember, cosine of pi over 3 radians was 1/2. So this is 1 over 1/2, which is the same as 2. And then cotangent is the same as 1 over tangent. And tangent was what? Radical 3. So this is 1 over radical 3. But then if I rationalize, this is going to be radical 3 over 3. Okay, so I have all the trig functions of that reference angle of pi over 3. So then remember that the trig functions of the actual angle that we were interested in was sine of, what was it, 13, it was negative 13 pi over 3, right? And then cosine of negative 13 pi over 3. And then tangent, this was the original problem that we want to solve. We had to first solve what the trig function was of the reference angle, right, which we just did. So now we can finish this up. And we know all the values are going to be the same, but they might have different SIGNs, right, different signs. Okay, so this is going to be radical 3 over 2. This is going to be 1/2. I'll just leave a space there because I might have to change the sign. This is going to be radical 3. This is going to be 2 radical 3 over 3. This is going to be 2 this is going to be radical 3 over 3. But remember, I'm in quadrant 4, right? Remember, the angle is actually in quadrant 4. We went all the way around. We went clockwise around twice, and then an additional pi over 3. So this angle is in quadrant 4. Maybe we can see it right there. So therefore, what is positive and what's negative? Well, remember, quadrant 4, cosine and secant are positive. Right? Cosine and secant are positive in quadrant 4. All the other ones are negative. So that means cosine is positive. I'll just write a plus there just to emphasize it. And secant, right, is positive. All these other values are going to be negative. And that's it. So really all you have to do again is find the trig functions of the reference angle. And then that makes things a lot easier. Then we can get the correct SIG in later. All right, here's another example. Okay, so now let's say if theta equals negative 8 pi, find, again, the trig functions of the angle. So sine of theta, cosine of theta, tan theta, etc. Okay, so first we have to figure out what negative 8 pi, where that ends up being, right? Well, first of all, it's negative, right? So we have to go clockwise. And think about this, right? If I go 1 revolution, that's 2 pi, right? Negative 2 pi. If I go one more clockwise revolution, that's negative 4 pi, negative 6 pi, negative 8 pi. So it looks like I'm going to be right on the x-axis, right? My angle is going to be right on the x-axis. So this is equivalent. It's the same as 0 degrees, right? Or 360, but usually just use 0. It's the easiest. So it's the same as 0 degrees. So we know the sine of 0 degrees, cosine of 0 degrees, tan of 0, cosecant of 0, secant of 0, and so on. We just went over these, right? Remember, the sine is y over r, so that's 0. If you want to do it again, this is r is equal to 1. This point right here, I'll just make it a unit, right? So r is 1. That point would be 1 comma 0. This is x, y. So y is 0 over r is 1, so that's just going to be 0. Cosine is x over r, so that's going to be 1. Tangent is y over x, so that'll be 0 over 1, which is 0. Cosecant is 1 over sine, so that's going to be 1 over 0, which is undefined. And then secant of 0 is 1 over cosine, so it'll be 1 over 1, which is 1. And then cotangent is 1 over tangent, so that's also undefined. But since negative 8 pi is the same as 0 degrees, it's going to be exactly the same for those. So I know that the sine of negative 8 pi, that's got to be 0. Cosine of negative 8 pi radians has got to be 1. Tangent of negative 8 pi radians has got to be 0. Cosecant of negative 8 pi radians is undefined. Then secant of negative 8 pi radians is 1. And then cotangent of negative 8 pi radians is undefined. Right, because negative 8 pi is exactly the same as 0 degrees. And we're right on the axis. We're not even in any, we're not in any one quadrant, so we don't have to worry about that. So it's exactly the same as if the angle were 0 degrees. Okay, well, how about this? let's say you're told if secant of theta is equal to 13 over 5, and we know theta is greater than or equal to 0, less than or equal to 1/2. So that means first quadrant. Right, that's telling us it's in the first quadrant. Then we want to find let's say sine, cosine, and tangent of theta. Okay, so the way I would do this, I would draw a picture, right? We know we're in the first quadrant. We know that in general, that, remember, secant of theta is 1 over cosine of theta. And cosine of theta is x over r. So secant is going to be r over x. So it looks like my r is 13 and my x is 5. So in this case, say that's 5, r would be like this. So this is the angle theta, this is 5, and this is 13. So I know that, right? I know r is equal to 13, x is equal to 5. I could find y there, right? Because I have a right triangle. I could just use Pythagorean theorem. If I extract out that right triangle, right, if this is 5, this is y, and this is 13, then I know that 5 squared plus y squared is equal to 13 squared. So this is 25 plus y squared is equal to 169. And then if you subtract 25 from both sides, then I'm going to get y squared is equal to 144. And then finally, if I take the square root of both sides, it should be normally plus or minus, but in this case, it's a length, so it has to be positive. So y must be 12, right? So we just found that y is equal to 12. So now we can answer our questions, right? So we can find sine of theta, cosine of theta, and tan of theta. Because remember, by definition, sine is y over r, cosine is x over r, and tangent is y over x. So this has got to be, sine must be 12 thirteenths. Cosine must be 5. There should be r here. It's x over r. 5 twelfths. And then tangent is y over x, so that's going to be 12 over 5. And that's it. Those are our answers. So sine, whatever the angle is, we don't even know what the angle is, but it doesn't matter. We're given enough information to find the sine of the angle, cosine of the angle, tan of the angle. Okay. To actually find an angle, you would need what's called the inverse trig functions, and we're not going to have time to get to that in this class. Okay, here's another question. Let's say you're told if sine of theta equals -4/5 and theta is in quadrant 3, find the other trig functions, right? So find cosine of theta, tan of theta, cosecant of theta, secant of theta, and cotangent of theta. Okay, so, well, remember, sine, right, of theta is always y over r. And they're telling us that it's -4 over 5. So that means y is -4 and r is 5. Remember, the r always has to be positive, right? So the y, you can attach the negative to the y. We know that we're in the third quadrant. So here I would draw a picture. So R is 5. And this is -4. Right? Y is -4. Remember, this is like the point X, Y. And this is R. -4 because it's downward. And the X we know is going to be negative something, right? We don't know yet, but it's going to be negative something. And this is the actual angle if we measure it from the positive x-axis. Okay, so how do I figure out x? Well, I can use Pythagorean theorem again, right? So I know that I have this right triangle. This is length 5. This is, so now I'm not going to put negative because it's just a length. I'm using a right triangle now. So this is length 4. This is x. So I know that x squared plus 4 squared is equal to 5 squared. So x squared plus 16 is equal to 25. And if I subtract 16 from both sides, I'm going to get x squared is equal to 9. So then if you take the square root, again, normally it's plus or minus, but in this case it's a length, so it's going to be positive 3. But we know we're in the third quadrant, so actually x is going to be equal to -3. Right, because we're in that third quadrant. So this value is actually going to be, this point right here is going to have the coordinates -3, -4. Okay, so now I can answer all my questions, all right? Just based on that. So I know that x, I'll write it down here just to remind you. So x is -3 because we're in that third quadrant. Y was -4 and R is 5. So just by definition, right, I can find sine of theta, cosine of theta, tan of theta, cosecant of theta, secant of theta, and cotangent of theta. So actually, sine they already gave us, right? It was -4/5. But we know in general it's going to be y over r, right? So it's -4/5, but they gave us that. Cosine is x over r. So that's going to be -3/5. Tangent is y over x. So that's going to be -4/3, which we can cancel the negatives. This is just 4/3. Then cosecant is 1/sine. So this is the inverse of that, right? It's r over y. So this would be 5/-4, which you can write as -5/4. Then secant is 1/cosine. So this is going to be r over x. So this is 5/-3, if I can write it as -5/3. And then cotangent is 1/tangent, so this is x over y. So this is going to be -3/4, but then the negatives cancel, so this is just 3/4. And that's it. Those are our answers. So often it helps to draw pictures, right? And use Pythagorean theorem to get the unknown side. That comes up often. Okay, yeah, let's do one more example. Okay, let's say you're told the terminal side of angle beta in standard position, so measure from the positive x counterclockwise, should be in, so in standard position goes to the point negative 9, 10. And based on that, I want to find all the trig functions of the angle beta, right? Sine of beta, cosine of beta, etc. Okay, so draw a picture, right? So here's my picture. If I know that the angle goes to the point negative 9 comma 10, so if this is like negative 9, let's say this is 10, this would be the point, right? So we're told that the angle goes through that, so this must be the angle beta. It's in standard form. So this point right here is negative 9 comma 10. So that's like my x and y value. And then we could also figure out r too, right? If you want to go from here to the point. How do we figure out r? Pythagorean theorem, right? So I know that x squared plus y squared is equal to r squared. So I have negative 9 squared plus 10 squared is equal to r squared. So this is what, 81 plus 100 is equal to r squared. So I'll write it this way, r squared is 181. And if I take the square root, that'll give me r. If you want an exact value, it's just the square root of 181. If you want an approximate value, this is around, if you plug it into a calculator, around 13.45. Okay, so then all we do is we use the definitions again, right? So now we know, let me write it down here to clarify. We know x is negative 9, y is 10, and r is around 13.45. So if I want to find sine of beta, cosine of beta, tan of beta, cosecant of beta, secant of beta, and then cotangent of beta. I just use my definitions, right? Remember, sine is always y over r. So this would be 10 over 13.45. That's around 0.74, right? We'll just approximate. Cosine is always x over r. So that's going to be negative 9 divided by 13.45. So that's around negative 0.67. Tan is y over x. So that's going to be 10 over negative 9. So that's around negative 1.1. Cosecant is, it's 1 over sine, right? So if sine is y over r, this is r over y. So this would be 13.45 divided by 10. So it's 1.345. I'll round it 1.35. And then secant is 1 over cosine, but cosine is x over r. So this is r over x. So it'll be 13.45 divided by negative 9. So this is negative 1.49. And then cotangent is 1 over tangent. Since tangent is y over x, this is going to be the reciprocal x over y. So this will be negative 9 over 10, which is negative 0.9. And that's it. Those are the values of that angle beta. Okay, and then again, to find the angle, that's a little trickier. For that, you would need inverse trigonometric functions. Okay, that's all I want to talk about for this section, for 7.4. So there's actually just one other section I want to talk about for this class, and that's on vectors. I want to talk a little bit about vectors. We won't do too much, but I want to at least discuss a little bit about vectors, just in case some of you will be taking physics with us. All right, great. Thank you.